Let's roll, man. Going slow. Just talking about tardies and if we got demerits or not. You had two. Is it both in this class? Like 10-minute tardies? I think those should be bonus tardies.
Started though.
Oh yeah, we started. We just been gossiping. Okay. So to solve for theta, what do we do? Can you get cosine by itself? So remember that you can, for the final, you can take whatever notes you want or feel like you need. So you might want to start that sheet today. One sheet, one back. What do we do here to solve for theta?
Cosine inverse.
Cosine inverse.
What? I don't know.
101.5. No, I don't think so. Or is your calculator in radian or degrees? I mean,
It was before, right? I got 101.5.
oh, I thought you said. Okay, something else. My bad. Yeah, that sounds reasonable. Okay, here's the thing though, and this is the part you guys might have forgotten. It says for answers between 0 included, yeah, and 360. 360 is not included. Okay. So, where else, what quadrants is cosine negative in? You guys remember this?
Is it first?
Okay, cosine is kind of based on the x value, so it's positive where x is positive, and it's negative where x is negative. That might be a note for you. And you guys remember sine? Sine is kind of based on the y value, so it's positive where y is positive. And tangent just kind of alternates. Tangent is positive and negative. What's new? Tangent is based on y and x. So anyway, that's how it works. Okay, this answer that we got, what quadrant is it in?
First.
Second, right? Because this is 90 degrees right here. So that'd be about right there. So that's our second quadrant answer. And we need a third quadrant answer. How do we find our third quadrant answer? Well, basically, all the angles that have the same reference angle give you the same ratio. So how do I find the reference angle for this guy right here?
180 minus 101.
Right. The reference angle is how far it is from the x-axis. Over here, the x-axis is 180 degrees. Over here, it's either 0 or 360. So if we do 180 minus this, 78.5, that would be the reference angle. Now that's not our answer, but that reference angle helps us find what our answer in the third quadrant will be. So,
270 minus 78.
yeah, we do 180 plus 78.5. And that is it. Okay, number 3 is kind of the same. Is it really warm in here? Whoops. It's like humid or something?
You just left. Do you guys have to do the major and the minor axis? No.
No.
Took that off.
Yeah.
If it gets worse, I'll lower it. I did not lower it. Alright. Number 3. Kind of the same thing. Okay, you will need to know like SOHCAHTOA and all that stuff. That's more next chapter. We'll do that tomorrow. But 3 is 3 minus cosecant x equals 7. Okay, so how would I start this one?
Try 3.
Oh, in the directions say we have to use 0 to 2 pi, which means we should be in radians. Now, subtract 3, you want to get cosecant by itself. Now what?
You can, well, take out the negative.
Divide by -1. Okay, that'll just make it -4, right? Fast forward that. Okay, I'm guessing we forgot this.
You can is the reciprocal equal right there?
Yeah. What's the reciprocal of cosecant? You guys remember this? Sine. So if you make that sine, then you have to flip this one as well. So it's negative sine of x equals -1.
And then sine inverse.
Okay. This is the point where your calculator being in radians is necessary. Because the directions said they want the answer in radians.
-0.25.
I don't know. Did they tell us where it ended? 100th? Yeah, okay. Negative 0.25 is not between 0 and 2 pi. It's below 0. So, where is negative 2.5? Well, it's over here going this way. Remember in radians, this is like pi radians or 3.14. This would be like 1.57. Okay. Well, going backwards anyway. This would be positive 1.57. Okay, what quadrant? So sine equals negative in what quadrants? Third and fourth. We just talked about that right there. Third and fourth quadrant. So this is kind of the fourth quadrant answer, except for we can't use it because it's not between 0 and 2 pi. So how do we change it to a positive version?
2 pi minus.
2 pi minus 0.25. 2 pi is also 6.28. So 6.28 minus 0.25 gives us 6.03. Okay, so that's the fourth quadrant answer right there. And sine should also be negative in the third quadrant. How we find the third quadrant?
3.14 plus 0.25.
Right. This 0.25 is basically the reference angle because it's how far we are from the x-axis. So to find this angle, you need to go 0.25 away from the x-axis. So 3.14 plus 0.25. Kind of a lot to remember, isn't it?
When is senior chapter?
Today.
Normal chapel time.
I thought it started at 9.
Oh, does it?
Yeah,
So,
that's
this one's at 9:30.
9:30?
Yeah.
I need to figure that out. All right. Yeah, we didn't do 4. We did do number 5. I don't think I'm going to pass out graph paper. Sorry. There's only a couple on here. You'll survive. I'll do it without graph paper too. Alright. Okay, before we do that, let's go back in time to a simpler time. there's like 4 things that can happen to a trigonometry graph, trig graph. So, let's see if you guys remember. What is this 3 gonna, you guys, okay, actually let me back up a little bit more than that. You guys remember what a basic y equals sine of x looks like?
So you just go into the middle, just going up and down.
Yeah, it starts out the middle going up. How high does it go?
1.
1. And it goes down to -1. That height is called the amplitude. Okay, the height's called the amplitude, and what's it called where, how long does it go before it repeats itself? What's that called? I kind of missed that.
Amplitude. Or,
It's called the period. There. So how long it gets before it repeats itself is called the period. On a normal sine or cosine graph, the period is 2 pi. Remember how I had you guys split this into 4? You know, we went from like middle to top to middle to bottom to middle to top, like that. Okay. What is this 3 going to do to this graph?
we go faster.
No, that's the amplitude. So that means it should go up to 3 and down to -3. So the amplitude on this graph is 3. Okay, what's the 1/2 going to do to the graph? It is going to affect the period. So normally the period is 2 pi, but if there's a number in front of the x, you do 2 pi divided by that number. So 2 pi divided by 1/2 is 4 pi. So that means that's how long it would take before the graph starts repeating itself. Okay, what's this? You guys should know this from a bunch of stuff. What's the -2 going to do to the graph?
2.
Left.
Right 2. And what's this do? Up 3. So that would kind of be like the center of the graph. You have to start right 2, up 3. And then from there you'd have to go up 3 and down 3 for the like ceiling and floor, because that's the amplitude. And then anyway. So given all that, let's go back to number 5 here. So what's this 3 do to the graph? Yeah, it tells you the amplitude. Now notice there's no like +2, -1. There's no numbers added or subtracted. So the center's still going to be at 0, 0. But the amplitude is going to be 3. Okay, what's this 2 going to do to the graph? Well, sine of x over 2 is the same thing as sine of 1/2 x. So it's going to affect the period. So normally the period is 2 pi, but on this problem it's going to be 2 pi divided by 1/2. So it's 4 pi. Just like that, my example over there. So when you go to mark your graph, just like on the 4th mark, unless the graph's already made for you, sometimes we did that, you put 4 pi. Okay, sine starts in the middle going up. So you go top, middle, bottom, middle. Where does cosine normally start at?
At the top.
You can go backwards also. Cosine starts at the top, of course I have to go down from there. It's like you can sense it when I'm about to kick your table. Sit up. Yep. Okay, so on 6, we're supposed to find an equation for that graph. Does that look more like a sine or cosine? You could actually use either one, but it looks more like a sine because it's going up through the middle. So we'll call it a sine graph. Okay. Remember that number that was in front was amplitude. Leo, focus. And one time. Now Landon and Katie will feel the rest of our pain.
Do you still out Landon? Right? You gotta get him, I'll throw this straight at you.
He will do it.
Linda's like,
It's not even worth it.
okay. So the number that goes in front is the amplitude. So what is the amplitude on number 6?
2.
2. Because it's going, if it starts at 1, it's going up to 3. That's an amplitude of 2. It's going down from 1 to -1. So the amplitude is 2. It is a sine function. What is the period on number 6? How far does it get before it starts repeating itself? 4. It's not 4 pi, it's just 4. So one easy way to do it is like look at the hilltops. So one of the hilltops is at 1, the next hilltop's at 5. How far is it from 1 to 5? It's 4. So the period is 4. So what goes right here? It's not 4. So you take the normal period 2 pi and divide it by 4. Which would just reduce to 1/2 pi or pi over 2, the way the book wrote it. So we got another one of these. Okay. And is the graph shifted left or right any? No. How can we tell? Because it's still going through the middle at sine, which is what it's supposed to do, so it's not moved left or right. Is the graph moved up or down any?
Yeah.
Yes. So the middle of the graph is where?
Up.
It's up 1. So yeah, you put a +1 out here.
Yay. I did it.
The middle of the graph is at y = 1, which is up 1. So you kind of have to always look at the middle. That's the key.
That means we get to do that.
No. Oh, do you guys remember number 8? I don't think I want to do number 7. Takes too long. I don't. I'm pretty sure I didn't put 7 on the test. Or I might have to remake the test anyway. But I usually try to be a little bit nicer on the semester finals, but maybe not that nice.
Put like 2 questions.
Okay.
What if you give one of
Like the answer's like 2.
All right. Let's talk about properties of these trig functions.
Cotangent.
So let's see if you guys remember this one. This is probably the one we use the most. Sine squared plus cosine squared. Remember this one? Equals 1. Okay, this would be a good thing for the notes. And it's used on problems like this.
Write that down.
How about the... And by the way, you can also transform these, right? Like if you subtract cosine squared on both sides, for example, you get sine squared equals 1 minus cosine squared. Okay, this is the same formula. Basically, if you have a sine squared and cosine squared, it's this. Somehow it's over here now, my word.
What happened?
Need love.
Oh my God.
You love the red
Not a backdoor exit. Okay. Is it just me? Is my nose too sensitive?
I'm breathing through my mouth.
Yeah.
But then you're just breathing in
The way it's getting all in your lungs. Think about what's getting in your lungs then.
Yeah.
It's better than
It's all gonna get in your lungs.
Yeah, no
The
matter
same
what.
spot.
You
geometry.
Because you know when you smell something, that's
Just go
you're
ahead.
actually ingesting something. All right. Another thing that you'll probably need this one too. You guys remember what tangent was equal to? Sine over cosine. Okay, which means cotangent. Cotangent equals cosine over sine. Okay, those were the ones that were like special that I said you had to have these memorized. But you also need to know that, like secant, for example, what's secant equal to? Okay, it's like 1 over cosine. You guys remember that? So you need to know the reciprocal functions as well. Secant's like 1 over cosine. Cosecant is 1 over sine. Okay, cotangent is 1 over tangent, but you probably want to use this version instead. Because the main trick that I had you guys use on these problems was just turn everything into sine and cosine that you can. So that probably should cover it for these problems. I probably put like 2 of these on there, maybe even 1 actually. I don't know. There's only so many problems, you know, can't do them all. Probably 1 actually. We'll do a couple of these. So. What can cotangent turn into? Alright, so usually when I work these out, I kind of drop the angle. Okay, what does secant turn into? What about cosine? Let's leave cosine as cosine. There is actually a way you could add these together. You wouldn't want to do it in this case, but like get a common denominator by multiplying this by cosine here and here. That'd be cosine squared over cosine. Actually, that maybe is the way to go on this one. There's more than one way to do these. Okay, so if I multiply the top and bottom by cosine, I get this. Why is that helpful? Because if they have a common denominator, they can actually join. They can become 1. You guys follow that? Okay, what's 1 minus cosine squared equal? Yeah, that's right. Comes over here. One of the versions of this equation is that 1 minus cosine squared is sine squared. Sine squared is like sine squared over 1, right? You could, whoops, I forgot the denominator. There we go. Okay. How do we multiply 2 things together? Remember when you multiply, you can cross cancel, like 4/3 times, or 3/4 times 2/3, like those cancel out, right? Those can reduce. That's how multiplying fractions works. So cosine can cancel out. One of the sines cancels out. And the answer is...
Wow.
Remember all the fun we had in that chapter?
I remember getting a B on that.
I can't believe you took that from her. We don't have time for that. Let's look at number 9, I guess. Moving like molasses here. 2 cosine. I think on our last day, which is our last normal day, Tuesday,
Yeah.
I'll just look through the test and like try to warn you about anything that I'm afraid I need to cover again or we might miss. Like try to find the hard stuff. All right. Any ideas what we could do on this one? It's kind of related to what we just did. So if we divide by cosine, that goes away. What's this turn into?
Isn't that like tangent?
Tangent, right? Okay, then we get an equation we can solve. It's like number 2, the first problem we did. So how do we solve this for x? There you go, tangent inverse. And depending on what the directions say, I guess it says radians. Number 10 it says.
1.107.
I don't have the answers in front of me. 1.107? Wait.
It's in radians.
Oh yeah, that's right. 1.107.
That's about it, right?
It probably said round to the hundreds place again. Okay. Tangent is positive in the first quadrant, which this is the first quadrant. And it's also positive in the third quadrant. So this would be like the reference angle basically. It's the first quadrant angle. It's how far it is from the x-axis. So to find the third quadrant angle, you would do that plus that.
4.25.
So. Too much fun, what's that mean? It's like too much money. There's no such thing.